Okay, thank you very much,
Thank you.
Mr. Chairman, for introducing me. Can you hear me? Hear me? Okay.
Yes, proceed.
Okay. Okay. I also thank all of you for attending this presentation of our work entitled Silage Production from the Residues of Plantain and Nutritional Analysis through Process Simulation. I am Óscar Sánchez, a researcher at Universidad de Caldes in Colombia. This is the outline of my presentation about our work related to exploring a new way through process simulation for valorization of waste from agro-industry of plantain, an important agricultural product in Colombia, a tropical country where significant layers of population use plantain as a source of calories in the form of starch for preparing food. This is the plantain is a product very similar to banana, but while banana is consumed as a sweet fruit, plantain is used mostly in a green stage for preparing soups or in a mature stage for preparing fried snacks. The most consumed variety is the Dominico Arton clone for its starch content and sensorial properties. The cropping and harvesting of plantain generates important amounts of waste materials, like the pseudostem, the rachis wasted, and even some rejected fruits because of its appearance or small size. So our proposal is that feed for dairy cattle, specifically silage, can be produced from these residues from plantain agro-industry. So the main aim of our work in the context of bioprocess systems engineering is to evaluate silage production as a way to valorize waste from plantain agribusiness. Main methods we used for our work involved the calculation of mass balances using the software SuperPro Designer, a simulation software that works very well for biotechnological processes with solid materials under batch regime. Finally, we globally analyze how this simulated process can be integrated in the overall design of a future second-generation biorefinery for processing plantain residues that we are developing currently. For this, we have performed an extensive and comprehensive search of information in different databases and technical documents. For simulation, in SuperPro Designer, it's necessary to define the batch size. For this, we have considered the historical plantain production data from 2007 to 2018 in Caldes province, that is located in the central western region of Colombia, among the mountains. Then, forecasting tools as linear regression analysis, simple moving average, weighted moving average, and exponential smoothing were applied to this data. For simulation in SuperPro Designer, the physical chemical properties of the compounds involved in the process from specialized databases, software calculation, and bibliographic sources were introduced into the simulator in order to calculate the batch size. In this slide, you can see the different formulas we apply to perform the nutritional analysis from the simulation results for both the residues and the feed products. Here, you can see the nutritional parameters used as a reference to design the product from specialized sources for dairy cattle feed. And, and this is the composition of the product, the silage, that we took into account in our simulation. This composition involves 95 kilograms of plantain waste for 100 kilograms silage. This is an overall scheme of the simulation procedure we have performed to analyze the process for production of silage from plantain waste. In general, we define the first operation unit or process and the input and output streams. Then we specify the so-called unit procedures such as transfer, load, react, mix, discharge, etc. And we calculated the material and energy balances for that first equipment. After that, we added the following unit operation or process and repeated the procedure until the final product is obtained. At the end, we performed the economic evaluation and generated the corresponding reports. As a result of our work, we defined the block diagram of a process for producing silage using plantain waste. This process includes different process steps such as chopping, washing, grinding, mixing, and packing. From the several methods applied to forecast the production of plantain in Caldes province, we chose the weighted moving average method, considering that it had the lowest mean absolute deviation. So the forecasted production for the year 2019, the year of the evaluation, was about 264,000 tons. Then we selected these waste streams, for planting agribusiness for subsequent analysis by simulation. Pseudostem, that includes the leaf sheets and the floral stalks, and the rashes, the bunch where the fruits are attached to, and rejected fruit. This total quantity in kilograms per day is the value that we have used at the beginning of the simulation in SuperPro Designer software. This is the process flow sheet that we defined and simulated, as well as the Gantt chart. This chart shows the scheduling of each operation included in the process. Remember that this process operates at batch regime. This table shows the final results from the simulation of the composition analysis of the silage obtained. This table follows in the next slide. Notice that the energy for lactation is above the reference value established by some specialized organization as the Spanish Foundation for the Development of Animal Nutrition for Dairy Cattle Feed. This value should be higher than 1.5 megacalories per kilogram dry matter in the feed product. So the product, our product meets this requirement. As conclusions of our work, we highlight that considering the available literature, computer-assisted simulation was used for the first time to design and nutritionally evaluate the production of silage for feeding dairy cattle from plantain residues. Obtained results indicate that silage is a viable solution for the valorization of residues from plantain agro-industry. Process simulation represents a powerful tool for the design of the different stages for producing different types of food products for ruminants, taking into account their specific requirements and the possibility of using agro-industry waste of wide availability in the context of each country. Finally, I want to thank all these institutions, the Universidad de Caldes in Colombia, Universidad de Dominio in Braga, Portugal, the Colombian Ministry of Science, and the Portuguese Foundation for Science and Technology. In particular, this study was supported by the Portuguese Foundation for Science and Technology under the scope of the strategic funding. This is the information of the Center of Biological Engineering at Universidad Dominio, and this is the information of our research group on food and agro-industry at Universidad de Caldes. Thank you very much for your attention.